move forward to the very first session of this FDP on innovative insights into signal processing and communication. It's my honor and privilege to introduce the distinguished resource person of the first session, Dr. R. Murugan. He has received his BE degree in Electronics and Communication Engineering and ME degree in Embedded System Technologies from Ananasti, Chennai, Tamil Nadu, India, and a PhD degree from Information and Communication Engineering, Center for Research, Ananasti, Chennai, Tamil Nadu. He worked as an assistant professor in the Department of Electronics and Communication Engineering, Ali Muhammad Saleh College of Engineering, Chennai. He worked as an assistant professor in the Department of Electronics and Communication Engineering, St. Peter's Engineering College, Hyderabad, in the year of 2018. He has published over 120 research articles in various international and national journals and conferences. He is a fellow member of IETE, a senior member of IEEE, and a life member of the Indian Society for Technical Education, ISTE India. He is the chair of the IEEE Signal Processing Society, the joint chapter of the IEEE Kolkata section, and IEEE Silchar subsection. He received an Outstanding Reviewer Award from Biomedical Signal Processing and Control Elsevier Journal and the Best Paper Award from various flagship international conferences. He is an invited reviewer of many journals, including IEEE Transactions on Medical Imaging, IEEE Internet of Things, Journal of IEEE Access, Biomedical Signal Processing and Control, etc. He received a Young Researcher Fellowship from DST, SERB Government of India for the project, a nationwide study on retinal detachment in India with emphasis on the risk of the fellow eye through fundus images using deep learning. He is the recipient of NVI DIA Academic Hardware Grant Program for the diagnosis of retinal pathologies using deep learning project. He is also the recipient of Technology Development Grant from IIT Indore Foundation under the National Mission for Cyber Physical Systems for the project modeling and design of affordable cyber physical system for diagnosis of retinal detachment through fundus images. His area of interest include biomedical signal and image processing, medical imaging, retinal image analysis, computer vision, and so on. It's an indeed pleasure to have such an eminent resource person with us today. Now I request our resource person to take over the session.
Yeah, thank you so much. Yes, can you hear me, madam?
Yes, sir. Your voice is audible.
Yeah, thank you so much. Yeah, thank you for the nice introduction. I thank the organizer for inviting me in the wonderful faculty development program to share my thoughts. So let me share my screen. Yeah, I hope my screen is visible to all of you.
Yes, sir, it is visible.
Yeah, thank you. Yeah, so once again, good evening to one and all present here. Yeah, so today I'm going to present a topic like, it is an interdisciplinary topic, which is completely related to the biomedical image processing. So how this particular topic is going to address the scope of this particular FPP, it is generically addressed, the development of, communications, IoT, and also your future applications. But, my field of, the research, which include the medical imaging, right? So in medical imaging, as you know, there are plenty of medical imaging modality generally exist. And, there are, wide scope the engineers like the technologists as, to connect with the medical applications and also to work with the recent technologies, which include AI, ML, DL, and also in a graph neural network, and to connect all these technology to form an interdisciplinary research. So I'm purely working on the interdisciplinary research, like which is starting from the technology development into the prototype development. So this particular talk will help you how to start a research from the retinal fundus image into an algorithm development. So once if you developed the algorithm, you have to simulate it. And after the simulation, you have to make it into the technology level and of course the TRL level. And you have to make it like a hardware and prototype. And finally, you have to go for a patent and IPR. You know. So in the last 5 years, I have been working in this particular eye disease, which is called retinal detachment. So currently, actually, I'm in one outreach activity. So here the internet connectivity is not much good. So I just want to hide my video so that you will get a very good, audio which I'm speaking. So that I'm just excusing my video to disable to all of you. Yeah. So like in this case, if you look at the title of my today talk is that there are twofold. One is that the diagnosis of retinal detachment, and another one is the detection of the retinal detachment. So, how the diagnosis and detection is carried out with the help of all machine intelligence model. Okay? So, what the technology, the GPS has been addressed. So, all these actually comes under a part of the today talk. And of course, specifically the imaging modality which have been taken is that the color fundus images. Okay. So what do you mean by color fundus images? Like, say for example, yeah. So the retina, everybody know that the retina is one of the part of our human eye, right? So in the human eye, to capture the retinal image with the conventional camera, it's a very, very challenging task because we require a specialized camera, then only we can able to capture or acquire the retinal image. Since the retina is located the backside of the human eye, so we require a specialized camera. So this particular camera you can able to find out in all the radiological center or maybe in the department of ophthalmology in any of the medical colleges. Okay. So and like mostly it will be available in all the eye related clinics. You can able to find it. So with the help of the fundus camera, the name of the camera is actually a fundus camera.
Sir,
So we are acquiring
excuse
an
me, sir.
image. Yes.
Sorry for the interruption. Your slide is not moving, sir.
No, I'm not moving inside slide, madam. I'm
Okay,
just
okay, okay, sir.
describing the today topic.
Okay, sir. Continue, sir.
Yeah. So what do you mean by fundus images? The fundus image is nothing but it is the fundus is the camera, the company which is firstly invented. And with the help of the fundus camera, we are capturing the image. So then only it is called a fundus image. Okay, so I hope the topic which will be well described to all the audience, and of course, we'll getting into the today talk of the content. So before that, so currently I'm affiliating with the biomedical imaging laboratory. So I'm leading this research group for the past 7 years in the Department of Electronics and Communication Engineering from National Institute of Technology, Chilchar, Assam. So let us getting into the table of content of the today talk. Yeah, so for today, I would like to share some of the background information about the retinal detachment disease. And in addition to that, whenever the technologies which you want to do the research, we need to do a very strong literature aspect. So this presentation, I would like to highlight some of the glimpses or some of the research gap actually the researcher what actually carried out in the with related to the retinal detachment, then followed by the first two project I think the madam has been described in my introductory profile, like the two sponsored projects not only two, the three sponsored project, which is majorly related to the diagnosis of, retinal detachment. So we have worked from the scratch into the technology development. So that particular whole, the flow of the whole work, which will be starting from the machine learning approach, then followed into the deep learning approach, then also which will also help to use in the graph neural network. You know, in the deep learning era, everyone knows, the past 20, 25 years, everybody is talking about deep learning. But now what happened? The technology is slowly outdating the other technology in the neural network, which is comes under the graph neural network. So we are also actively working in the area of graph neural network. Then we are also demonstrating a product in the graph neural network technology. So that's why I have framed from the scratch into the recent technology so that the participant can understand from the basics into the advanced. Then I also, the whole talk, which will be in a two category. One category is the classification of the retinal detachment through the whole AI framework, and also which will like to perform a segmentation and visualization of the retinal detachment lesions through fundus images, right? So this particular work, which our chief guest has been highlighted, the VR technology, virtual reality technology, right? We also working with the virtual reality technology for understanding about the medical, or we can say the retinal detachment lesions accurately, right? There are so many technology which is involved in this biomedical imaging talk. I hope the particular talk can help you to get into a new insights into this particular area. Now, let us share some of the very, the interesting uh, background of the retinal detachment disease. As you can see here, you know, first we want to define what is retinal detachment. So what is retinal detachment? So it is one of the visual impairment. What is meant by visual impairment? So we can call it as it's like a eye disease. Okay. We heard about many eye diseases like cataract. We have heard about it. Sometimes we heard about it. Glaucoma is also another eye disease. And also we heard about, diabetic retinopathy, like many eye diseases you may heard about. And, and very rarely you may heard about this particular disease, retinal detachment. So what is the effect of this particular eye disease? So this eye disease, what happened, you look at the particular anatomy of the eye, which have been given in this slide. You can see here, the retina is actually located, the back side of the human eye. You can see here, the whole layer is actually, it is called retina. Okay, it's called retina. So what happens over the year, the retina may be displaced from the original position. Okay. So in a imaging language, what we used to call, it is called detached. So that's why the name of the disease is called retinal detachment. Okay. You can see here, it should be, the retina should be like this, but what happened, you can see here, it is detached. So that means the retina has been changed from its original position. Okay. So this is the nature of this particular disease in terms of imaging. So why it is happened, how it is happened, there are large historical issues or news which we need to learn. But majorly, like say, it may happen sudden or over the time. You will not get any proper symptoms, whether you will be going to affect this particular disease. Suppose if it is considered an example of the eye disease, which is called diabetic retinopathy. So generally, the diabetic retinopathy disease will affect for only the diabetes mellitus people. The people, those who are having a diabetes disease, So they are having a chance to affect a diabetic retinopathy, and the diabetic patients has to be periodically screened by the ophthalmologist. Then only they can prevent their vision. So, but this disease is very, very dangerous disease. You will not get any proper symptoms of it due to the eye pressure or due to the over stress of the human being. So these conditions may occur. Okay. So immediately what happened? Your retina may be misplaced from your position. Then after, what happened? You may be gradually lost your vision. Okay, that's why it's called a visual impairment, and it will, not treated properly, it will lead to the blindness. Okay. So this is the nature of this particular disease, and why we are talking about this particular disease in India. In most of the developed countries, like US and other countries, they are affecting this particular disease. But in the recent time, in the last 10 years, the Indians also affecting with this particular disease with large numbers. Okay, the reasons are many, but this is the statistics we can say. Now, to move ahead, what happened? Like if you knowingly, unknowingly, if you want to came to know about this disease, now you can look at the statistics of this 2024 of this particular disease, the retinal detachment. With this particular statistics, the technologies like us, we are actually getting motivated to work in this particular disease. You can see here, in most of the cases, the retinal detachment disease is affected by the person, those who are reaching the age of more than 55 years. You can see here in the age range. And you can see here for the developed countries like US, Netherlands, Scotland, England, even including China, Singapore, Korea. You can see here the annual incidence of the cases which have been affected by this particular disease, in 12 to 18 and 13 to 14 and 7, like this. But if you look at the last row of the particular the statistics in India, you can see here it is varies from 6.3 percentage into 17.9 percentage is per 1 lakh patients. You can see here for this particular statistics in India, it is a large in numbers. Okay, so people are affecting by this disease. But what happened in many of the rural area, they are unable to, diagnose this particular disease. This is we have been affected by the retinal detachment. This is the nature of this particular disease. Okay, so the statistics is large, the numbers are large. That's why we actually committed to work with this particular disease. Now, if you look at, as I said, the patients, those who are actually going to affect by this retinal detachment, they may get very, very minute symptoms, in their visions. You can't get, the much, symptoms to understand whether we are going to affect this particular disease, but there are very, very, the small lesions that has to be happened that we consider as the symptoms of this retinal detachment disease. So that we used to call the early indication of this retinal detachment. So there are many early symptoms, but majorly there are three symptoms which include flash of light. We can see here in the first line, and curtain, the shadows, like a shadows in their image. You can see here some of the portions, it is totally blurred, and you can see some of the portions. And you can see here, while looking into the eye, you may get a lot of increasing floaters. You can see here this type of floaters, right? This is very, very early symptoms of actually the retinal detachment, which you can say. But if you are having this type of symptoms, so you just immediately consult your eye doctor, then only we can able to prevent your vision from the detachment. Now, if you look at this particular slide, there are different types of retinal detachment which we can categorize. And the image is actually majorly given in most of the insights into it. And majorly the retinal detachment is classified into three categories. One is called rheumatoneous retinal detachment. And second one is the tractional retinal detachment. And third one is the exudative retinal detachment. You can see in the first figure, it is the normal retinal fundus image, which is captured from the retinal fundus camera. And there is no abnormal symptoms in this particular image. And if you look at the second image, the rheumatoid retinal detachment, which you can see here, there are small portion of the retina which has been displaced. You can see here, the whole imaging, or we can see the qualitative changes in image. And if you look at the third image, like, the whole portion of the retinal detachment, which will be majorly, the covering into the entire portion of it. So that's why the persons or the patients, those who are affected by the retinal detachment, actually they are, they gradually losing their vision. And if you look at the third category of the exudative retinal detachment, so you can see here in most of the places of the retina, it will be occupied by the abnormal, the lesions. And of course, you can see here there are, the blood clot also inside this retina. So what happened, in most of the portions, it will be lost their vision. So this is called an at the advanced stage of the retinal detachment, and of course, you can see here the corresponding image changes in this particular disease. Now, coming into the research aspect, identifying this disease manually, right? It is one of the very, very challenging and typical tasks. We required like a experienced ophthalmologist. We required the experienced eye doctor to find out this disease. You know, even though if you have an eye doctor, and based on their experience, we have tried the decision actually is getting changed. So we require, yeah, the automated system to diagnose of the exact, the type of the retinal detachment. Accordingly, the treatment mechanism may change. Okay, so this is the main motto of the particular, uh, you know, um, the types. So why we are moving into the manual process into the automated process. Now, if you look at the motivation behind this problem is that, and of course, if you're coming into the manual, process, there are time consuming and we required a lot of labor and we required a lot of large scale clinical applications and we required, many manpower which is involved. And of course, it is the complicated task. Okay. So with this motivations actually, yeah, there are urgent need of an automated but kind of algorithm to diagnosis of the retinal detachment. Yes. Now look at the literature. Suppose if you want to carry out in any type of diagnosis or the classification problem or in any segmentation problem with respect to the image processing, generally we need to carry out a very, very strong literature, which is based on machine learning and deep learning algorithm. And also we have carried out many literature which is relevant to the graph neural network. And we also carried out the literature of the lesion segmentation and detachment. So we have carried out a strong literature. So from this literature, we have find out some of the very, very interesting research gap. So those research gap is generally given direct way to address in some of the research gap with our own research. So that may be a contribution to the, of course, the technology will reach into the common man, like what today chief guest has been addressed. So, which we have been find out many research gap. So this research gap is based on in image processing, and it may be based on the machine learning, and sometimes it may be based on the data. Like, if you want to work with an image processing, you require the data, right? So in all these, the nook and corner of this particular research gap, if you look at in terms of the retinal detachment, we have it, I mean, very, very limited publicly available data sets. Suppose if you are an image processing researcher, if you are a medical imaging researcher, if you want to work with the tech, in this particular disease, and you require the data, right? But publicly available data is very, very limited. And of course, if you want to work with, all this deep learning architecture, you required a huge amount of data, right? You required a bunch of data. Then only the deep learning network will address, or will get the good performance metrics. And if you look at in the deep learning, of course, you require, yeah, the labeled data. That is also the another research gap we can say. And also, as of the research, there is no effective multi-class classification techniques in retinal detachment. But now you can find, two of the multi-class classification of retinal detachment, which I have been contributed to this technical society, right? So then also, if you look at everywhere we are talking about the deep learning, but deep learning required huge amount of data. But for addressing this huge amount of data, if you have only limited amount of data, then if you have an imbalanced data, we can also use the graph neural network, which is the very recent, the deep neural network, which many of the researcher which will be working in this graph neural. Like we have n number of gaps, which is also include. Yeah, so it is not only to diagnose this retinal detachment. With the help of the fundus images, we can also work with the other medical imaging modality, which is called OCT, which is called optical coherence tomography. But this imaging is very costly, and also it is a three-dimensional image. But what we are talking about the fundus image, it is a two-dimensional. Okay, so and also to segment the proper portion of the retinal detachment, that is also one of the very, very challenging tasks. And we required, the complexity of algorithm and training time, and the computational complexity and other kind of issues that will also the gap to address this type of problems. So on the whole, like there are many limitations, or we can say that many research gap to work in this problem, but we have been addressed some of the research gap from this literature. So those gaps actually we can be able to, discuss in this coming time. As I said, the one of the foremost the limitations or the gap is the data sets, right? So there is no publicly available data set or retinal data set. So that we have created one of the publicly available data sets. So we have been collaborated with, the major four eye hospitals in India. And also we have been collected the bunch of data, and we also launched in the publicly available data set, which is publicly available. Then you can also download this data set. You can also work this particular, but this eye disease, retinal detachment disease, and the same way you can also contribute well in this particular domain. And also not only development of this retinal detachment data set, but also which we have been developed one of the very interesting machine learning model to accurately diagnosis of the retinal detachment through fundus images. So in the coming a couple of minutes, we'll discuss this particular contributions. So what happens is that, if you look at the creation of this retinal detachment data set, I have been the collaborated with the major hospitals in India, four hospitals. You can able to see the list. One is the Silchar Medical College and Hospital, which is in Assam. It is very near to our NIT campus. And also, very, of course, the Tamil Nadu state, like, the Aravind Eye Hospital is one of the very popular eye hospital in the state. So we have been collaborated with that. And also in Telangana, we have a very good research eye hospital, which is called LV Prasad Eye Hospital. And also we have covered in the North India with Medana, the Medicity in Gurugram. Okay, so with the help of all these four major hospital, we have been collected the bunch of data and we have been, uploaded in this particular data set, which is called retinal detachment data set, which is available in IEEE data port. Okay, so you can search in IEEE data port, the retinal detachment data set, you can be able to find this particular result. Because to work with this particular disease, we require the data. Once the data is ready, you can do even any or n number of data analytics. So initially, like in 2020, I have been started this project for collecting this retinal detachment image. But what happened over the time, we have been getting only the recombinant retinal detachment data, and also with addition with the normal data. Then what happened, the days comes, we are getting and we have updated our data set with the multi-class data. And also now you can find the multi-class data in the IEEE data port. Now, in this, the whole creation of the data set, now it is publicly available and anybody can work. So what we have been done from this particular data, initially, in 2020, what have been done, so we have only two class. One is RD and another one is a healthy data. Okay. And you can see here, so with the help of this two data, like we need to classify, whether it comes under the normal category or it comes under the abnormal category. So here what happened, we have been done a hybrid algorithm, which include a representation learning from the pre-processed data. And also we have used, a typical classifier, which will becomes under the hidden layer. And you can see here the whole architecture of this particular, the model which have been created. And finally, what happened, this 70% of data which have been trained this architecture, and also the 20%, 30% of the data we have been tested, and some data also have been validated for to prove the efficiency of this particular work. You can see here the typical CNN architecture which have been used, and also we have used representation learning that will be ultimately helping to get more, the visible or the visibility finding of the retinal detachment lesions. Then finally, it is classified to the RD and the image. Now, this whole architecture, you can find it in online. It's also available. Finally, I will share a list of applications which is involved in this particular work. And in addition to that, if you look at into the architecture development, you can see here the layered architecture of this particular model. Okay, so how many number of convolutions layer required, how many number of patch normalization, what activation functions basically involved. Everything actually given in this particular slide. And if you want to reproduce in such work, and of course these type of informations which is mainly available, then you can also use this architecture maybe for your own application. It's not only for the compulsory to work with medical, the retinal detachment classification, but also you can work with, some of other diseases, we can say. It is very generic for the computer vision problem, and you can select any of the classification. You can try to attempt. If it is yes, you can use this. If not, you can fine tune this architecture. Then accordingly, you can able to contribute a classification problem with this hybrid method. And in addition to the layered architecture, you can also see some of the performance metrics if during the training time or during the testing time, how actually the performance is varies. If you look at in the training, it's almost, it's more than 99% of training data which have been effectively trained by this architecture. The loss is very, very limited in this particular architecture. And if you look at the testing case of this particular architecture, is more than actually 96% to reach up to the 99% it seems. Okay. So these are all, the particular characteristics which will help you, to boost the efficiency of the particular architecture or the developed. To move ahead, we can see here in generally in cloud in the image processing, whenever if you want to classify any problem, you need to supply some of the the classification based performance metrics. You may heard about the confusion matrix. It's one of the primary performance metrics which you need to prove during the testing of the architecture. And also you can also test the ROC curve, the receiver operating characteristics of this particular architecture. That is also one of the very, very, the primary performance metrics. And these two help us to, to validate our work, which is how it is actually working. So if you look at in this case, when all these performance metrics are well defined and it is working well, and also we have been done many ablation study. Okay, suppose if you increase the layer, if you decrease the layer, wow, the performance is varying. So in all type of the ablation study which have been performed by this architecture, that actually reported in the slide. So not only in the validating or the performing the ablation study, but also we need to compare with this our proposed architecture with some of the pre-trained networks, which is commonly available, like say Google Linear, the Inception, ResNet, DenseNet. If you look at the whole comparative analysis, the proposed model should be performing very well than others. Also we have tried with how say for example if you taken the representation learning, it will taken the represent the whole imaging from the pre-processing steps, but at the same time you may heard about the transfer learning in deep learning. So the transfer learning is also one of the very important technique while during the training, which will be helping to effectively train with limited amount of data. And also what happened in comparison with the transfer learning. So our proposed approach is well categorized to the classification. So that way we can prove that, the what which we have been highlighted, it is very well classified. And we also have been performed many, comparative and, analysis. And we also done with many data growth evaluations to prove the efficiency of our model. Okay? I hope the whole work which we have been carried out will be well explained to the participant. I think if the similar way, if you want to carry out any research, I think you can able to perform in such a way that so that you will get a lot of insights, how to implement and how to validate and what are the experiment that we need to carry out to prove our efficient model. So whole thing which will help you. And of course, the summary of this work is that so the architecture with the help of representation learning, what we have been carried out, so which will be well performed, especially for the two-class problem of the vertical detachment. Okay, now coming into the to investigate various performance of the deep neural network. Say what happened one way, which we are developing our own neural network, or maybe the deep neural network. In other way, if you look at in the common deep learning framework, there are n number of pre-trained network which is available. Right? So whenever if you want to propose any new, the convolution network, you have to also perform the experiment with the pre-trained network. So then only you can effectively, propose some. So in that case, what we have been done, we have been investigated, all the, the performance of the deep neural network, especially the pre-trained network, with a different class, original detachment. So, this is also given a lot of, idea and why the particular network is giving good result, why the particular network is not up to the mark, so that with the help of the particular pre-trained network, we can develop or we can modify those particular pre-trained network. So accordingly, we can improve our classification accuracy. Okay, so in that way, this particular work will be, performed well in this case. Now, if you look at, there are plenty of, the pre-trained network which is available in the cloud platform, and you may heard about all this network like AlexNet, Inception V3, GoogleNet, VGG 16, 19, DenseNet 2.0, so many network which is available. But we have been done all the experiment in the help of our data set, and also we have been, it may leads to develop our own network for the management. So in this, the comparative analysis kind of thing, the method one is just like this, which we have been used the transfer learning, and which we use to pre-train. And you can look at this architecture, the flow diagram. We have been worked all the existing pre-trained network, and which we have been used for, the classification purpose. So what happened out of this all the network, the ResNet 50 network, which is actually given very good result. And in terms of comparison, also you can find, the result of ResNet 50 is very good. The reason is that you can see here, the ResNet 50, it is a 50 layer architecture, right? The number of layers are actually more. What happened? It is ultimately helping to effectively extract the feature information or the feature extraction from the data. So in that way, actually, it will give a very good result. Okay. So also you can have the ResNet network having many advantage, which include the stick connections or all other, the AI-based, the new techniques so that will ultimately helping to get the very good result, architecture. The similar fashion we have been carried out confusion networks in a receiver operating characteristics curve to prove which actually model is giving best results. Now, what happens is that if you look at the previous method, it's simply, gives the transfer learning approach, and the ResNet is actually given your result. So here what happens is that there is no novelty in the method one, but being an image processing scholar, we need to, propose the novel architecture. So in the novel architecture, how we can able to go for it and what are the network which can primarily consider what we have been done. So we have been taken the good results given network. One is the ResNet and also the Inception. So what happens is that, so this method, which will be combined with the inception ResNet architecture, and to get more, the visibility of the RT descents, we have also carried out some of the pre-processing steps, like, adaptive histogram equalization and RGB to HSV conversion, green channel estimation, and the red channel estimation. So these pre-processing steps, which will primarily helpful, to get more visibility of the image. And you can see here some of the sample image, which is also given in the figure 4.5, how actually this pre-processing is helping to get more effective feature extraction. And finally, the particular network is, classifying the RD from the T. Yes, so these are all the very well, the accepted performance and comparison. So to prove efficient of this particular method. Okay, so the whole work, what we have been done, which will be very, very interesting. And we have been working with the basic deep pre-trained network into the pre-processed deep neural network. And also what we have been done. So if you want to, go with the further contribution of this particular RDBCs. So what happens is that, so the first 3-2 method, which is primarily, diagnosis are classified with, the whole disease images. But here what happened, the other way which we can say here, how to diagnosis or how to classify the image, basically with, the early based symptoms. So in that way, what happened? We have been carried out an experiment which is based on hybridized deep neural network. So which include the VGG19 architecture, and in addition to the BiLSTM network, and we have been combined these two architecture. And that's what happened. That gradually, this hybridized deep neural network is well, classified with the particular early symptoms of this particular disease. Now, if you look at this figure 4.7, the whole architecture, which has been graphically represented to you, and how actually the whole, the BiLSTM is helping, and of course, what is the layered architecture. And here, for optimizing the hyperparameter, so AdaBoost algorithm, the optimization algorithm, which is also involved in this architecture, then finally it may helpful to classify these two, RD and non-RD. And in addition to that, which is also given some of the layered architecture of this particular one. So these are all the very, very common. So you can also go through this type of performance metrics, which is always helpful to, to write or to get a very good, write a publications or a journal work. Now, coming to up to what we have been carried out, whenever we are proposing a deep learning, we have to face a lot of challenge in selection of the hyperparameter. Okay, the hyperparameter, which is like, the what is the number of epoch, what is the learning rate, what is the training algorithm. They're all the very, very primary, hyperparameter which we need to select during the training process. But what happened? The hyperparameter selections, if you go into with the help of automation, with the help of optimization algorithm, that will ultimately helpful to reduce the overall computational time. Okay. So in this case, if you look at this work, which we have been carried out with the optimization algorithm. So one of the very, very famous optimization algorithm, which is called Gray-Wolf optimization algorithm, and we have used a typical convolutional neural network, and will also helpful to classify this RD from the non-RD. So the whole layer architecture performance evaluation is given to you. So finally, the slides will be sharing to Professor Chinaya sir. So he may be sharing into the participant, and I think so the similar fashion you may reproduce the works. Ultimately, it will help you. Okay. So in addition to the optimizations, we also tried with the different optimization algorithm, which is also with the help of the genetic algorithm. So how actually this type of classification is performing well, that will also actually we have tried, but even it is working very well for the classification problem. Okay, so the very basics about genetic algorithm and how the mutations and the crossover selection, which will be helpful to select the appropriate parameter. There are very, very basic fundamentals. So in research aspects, you can read all these things. And in also to perfectly classify the retinal disease, which I mean detachment disease, we also use the extreme learning machine classifier, so which will be very, very helpful even if the number of samples are increased. Okay. This is also a very, very interesting architecture. And we also tried with some other classifier, which include random vector functional length. And we have supplied all these type of results for the better understanding about the participant. Okay, so these are all very, very interesting part of the classification. But now, whenever we coming into the real time application. Say all this work, what we have been done, it will be reaching into the society and it should be primarily used by the eye doctor, right? But these architectures are very, very complex architecture and it's require a lot of computational time. So what happened for addressing the real-time problem and especially the telemedicine applications, the doctors are required very, very lightweight network, very small network. So then only we can feed in this network even our mobile application so that it will be helpful, to diagnosis of this particular disease. In that way, we have been done with the very, very small lightweight network, which we have been developed. And this lightweight network, if you look at the very good performance metrics, actually it is produced. And in addition to that, what happened, we have also compared with other lightweight network, which is previously proposed. And we can see here the whole network, which is very, I mean, good results which is given. So in that way, actually, this lightweight network, there are now the scope to implement it. But still, there is room to improve the result since this network is given only 96%. So then what happened? We have been attempted to increase the percentage of this result. Then in that way, we have been done a lightweight network with, performing a typical technology, which is include. And one is the handcrafted features, which have been included. And also the hyperparameters are optimized with gray wolf optimization. And the previous lightweight network, what we have been given, which is a binary class. But here what we happen, we have been also done with the multi-class classification of the retinal detachment. So this network is one of the very, very unique network in the medical imaging domain. So which also you can find it in online, which is available. So that this type of network can help you do a lot of research insights into it. Okay. So now coming to the whole deep learning network, primary network, which is the one. Another part, how it is going into the real time, the framework. So which we need to talking about. I mean, when we are going for the real-time network, we required a graph neural network, and we have also used the different graph neural network in this case. The advantage is that whenever we are going to use the graph neural network, we require a very, very limited amount of data, and the whole image, which will be converted into graph, and the graph is having n number of properties, which is like a node, a vertex, and in that way, we can able to perform very good, the feature extraction. So from the feature extraction, we can get a very good classification network seems. So due to the time limitations, so I'm just skipping some of the slides. So only the technical insights which I will be explaining to you. So you can see here with the help of this, the technology graph neural network, we have developed even the app, which is primarily used for Android. You can see the screenshot. So we can, Retinex, which will be, if it is open, we can able to, this particular lightweight network can helpful, to diagnosis of this multi-class classification. And so one way which we have been using this graph neural network for the telemedicine application. In other way, we have developed this graph neural network to import into the prototype, the hardware. Okay. So what we have been carried out, you can see here, this particular slide will given you because the networks are, very, very huge network, we require a super fast computer, right? To diagnosis. So what happened? We have used the Raspberry Pi, 4B model, and we feed into this particular model into the PyTorch. And this PyTorch, with the help of PyTorch, we have created a graphical user interface. You can see here this GUI, and once the image is, uploaded into the GUI, you can able to automatically diagnosis of this different category of the retinal detachment. You can see here, this is a very typical setup, experimental setup, and this is the Raspberry Pi inside in this case, and this is a display, and it is the front end. And just if you upload the image, you can see here the screen will be looking like this. Okay, and just browse and upload the image, and you will get the what type of image and what is the confidence score that will also getting for this particular applications what we have been developed. Then, like in addition to the whole classification, we can also, done the virtual reality based, visualization from segmentation of this retinal detachment. So once the image is collected, then we have done some augmentation. Then we have been segmented with the deep neural network. We'll also use the virtual reality based realization and finally make the form the evaluation by the ophthalmologist. This also actually we have been carried out, and this is the segmented neural network what we have been done. So this is the very neural network architecture, and this is a combination of the ResNet and the typical unit architecture, and it is actually given you a very good segmentation output. So these are all the different result which you can see here, and both qualitatively, quantitatively output, which is also given. So due to the time limitations, now we're almost engaged. So I'm just, if we conclude this work, you can see here the whole journey, it will be starting from the scratch into the end, and it will start from the literature to the technology development. Okay. Also, the technology is already patented. Okay. So I think if you follow the same workflow, maybe for your PhD work, or maybe for guiding more PhD students, or if you want to intend your own research, so the whole framework actually help you to make a very good technologist in the field of medical imaging. And also in the future, we are trying to use the different technology into the same analysis. So these are all the publications actually primarily involved in this particular work, what I have been presented, which include one Indian patent, and also we have a different publications and some of the conference works, and also abroad conferences, which is also given this. So these are all the outcome of the work what I have been presented today in front of you. Also, I acknowledge this two funding agency, which is funded to this particular project, especially to carry out from starting to end in the last 5 years. These are the references involved. Then I think the remaining time I can give you maybe for answering some questions so that I can give you the chance to speak about the other speakers in on time. So thank you so much for the listening, and I'm just expecting some very good questions from you. Okay, so there are one participant written in the chat. Thank you very much for informative. How can we collect data set for segmentation and classification? What is the procedure for obtaining data from hospital? That is a very good questions from Savariyappan. Yeah, yeah. So like the process is very, very simple, Mr. Savariyappan. You need to find a very good eye doctor, and maybe they are working and you just try to connect and and you talk about the where actually he is working, and you just collaborate with them officially. And once they supply the image, what outcome you may be, the credit you may be given to the hospital. So everything you just make it very clear. So in that way, actually, you will get the data. It's not a very, very big deal. But the only thing is that you have to be, a contact of the correct eye doctor, those who are primarily interested to commit into the research. So they may ultimately help you. Any other questions? When to use CNN, when to use graph neural network? Very good question, sir. Appasamy, Mr. Appasamy. So if you have a large number of data, if you have a huge number of data, you go for CNN. Suppose if you have very limited amount of data, you go for GNN. Okay, so this is the answer to this question. Any other question? How to access data in free way? It is available in online. You just log in and you can just simple registration where what is your login, I mean, you're working, where what purpose you want to download. And of course, automatically they may given the rights to download the data set. It's not a very, very big deal. Any more questions? Yeah, I think all are, thank you. No more questions. Yeah. Ma'am, can you hear me? Can you wind up?
Yes, sir. Any other question from the participants?
PSO algorithms used for feature selection. You can use, but mostly the PSO is very well for only feature extraction, also come feature selection. But what happens if you look at the literature, PSO is a very, very old algorithm. But now we have so many very good optimization algorithms came into the picture. Okay. So you can find, the gray wolf optimizer, whale optimization algorithm. These are all a well-defined algorithm than PSO. And these are all a very good algorithm which is actually working. So we have used PSO, but due to the less amount of percentage, we have used very recent optimization algorithm. Harris Hawk optimization, very good option. You can try. Okay, that is a very good optimization. We also, taken the literature, but we never used till now for our work, but you can try. Very good optimization. So some are asking my contact number. So it's very easy. You just Google it, Murugan NIT Chilcher. You will get my webpage. It's there, my mail ID, phone number, everything is available. So you can ping me anytime. Yeah, ma'am, please conclude. Already 8:05. I think
Okay,
other
sir.
speaker is waiting.
Okay, sir. Okay, sir. Thank you, sir, for your inspiring talk. And also thank you for taking your valuable time to share your knowledge with us. Thank you so much, sir.
Thank you so much.
Thank you, Professor, for having
Yeah.
accepted our invitation. Thank you. It
Yeah,
was a
so
very exciting and insightful session.
yeah,
It was result-oriented discussion. Thank you.
thank you so much. I will share the PPT. You can also share with participants. Sir. Thank you so much.
Thank you so much, sir.
Thank you.
Thank you, sir. Now we are